What we're going to do now is we're going to start drawing onto this screen. In game, just so you're aware, personally I'd leave this function at the bottom. You can leave it at the top or the bottom. It's completely up to you. The order in which functions turn up doesn't matter. But what you can do now is you can have two functions in here, tick and render, like so. So what we could do in here if we wanted to as well is just put a frame rate. Now I'm going to put a frame rate in here, which means I've then got to go back into here and put another frame rate in F, and up here. Okay, like so almost. This dot frame rate equals F. And then what you're going to do down here is just put the dot 0 there, which turns that into a double, and then divide it by this dot frame rate. Okay, we're on our draw function now. What we're going to do is first we're going to start up the top here. We're going to start by making a private buffered image. Buffered image in this one, which is called image, I think. Yeah, we'll call it image. And of course, we're just going to set this to be a new buffered image. We're not going to do that there though. Also, what we're going to do while we're up here, just make a new private integer array and call this we'll call it pixels. Okay. Now, why can't it include that? Just save it and it should include it. I think it doesn't. Okay, we'll just set it to do that instead. Now what we're going to do is, after we've made all this frame and stuff, we're going to do that this dot image, which is going to make it a new buffered image. And of course it's going to be width as a width, height as a width, and the last thing buffered image takes is just how it wants to store each of the variables, and in which case we're going to do type int argb. This will just mean that each pixel of that image is stored as a integer, and with 4 variables. I'll show you how we do that in a moment, with alpha, red, green and then blue. Next we're going to do this pixels, and this one I'm going to do a double bracket, and we're going to put this as data buffer int. I'm not going to put a double bracket in, because here what we're going to do is we are going to, in this bracket, so you want to put that in brackets in front of another bracket, and we're going to do image dot get raster dot get data buffer, and then outside of that bracket what you're going to do is do dot get data, I believe. I may be wrong. What we're going to then go and do is just quickly put all of that into brackets. Hopefully, yeah, that's it there. So what this does is just links our pixels array to our image array. So anything we change in the pixels array, we're going to change in the image as well. Over in draw here, we're going to this dot get buffer strategy. That's what I'm looking for. Sorry, my mind just went absolutely blank. We're going to make a buffer strategy, and we'll call it BS equals this dot get buffer strategy. Next, just quickly test to make sure that BS does not equal null. If it does equal null, we're just going to return. But of course, the first thing we're going to do is this dot create buffer strategy. Now, what you want to do with this is how many buffers you want. I always go for 3 because most of the games I make are 2D. Most of the games I make are 2D, so 3 buffers should be fine. So now we have BS stored. Next, what we're going to do is make a graphics variable. Just call it G equals bs.getDrawGraphics. Now you have to use the getDrawGraphics because obviously we're going to be drawing onto the screen. G.drawImage. Now what we're going to draw here is image. Start at 0, 0. We're going to use getWidth and getHeight as our W. I think that's everything we need. I may be wrong. That's wrong. Sorry, I'm really lost. What am I doing? How do you do that? Is that how it works? I've gone blank. Oh, the image observer, of course. No. I was looking at it thinking it's not enough variables. So basically what we're doing here is we're drawing image here, which obviously we've linked to our pixels array. And we're linking, and we're drawing that starting at 0, 0, finishing at get width and get height. Because just in case the window scales differently to how we have our thing set up. And then null, which is the image observer. And then g.dispose and bs.show. This will just show the image onto the screen with the new buffer strategy. I haven't actually played around with buffer strategies too much, to be honest. So, yeah, it seems pretty simple. And the last thing we're going to do here is just in this thing, we're just going to put render. Now, what render is going to do is basically the same as we've got tick here, except of course we're going to call it render. And the reason we do that is we come over into our game class and you see we have render. Now just as a quick test, we're just going to go to the int I equals 0, I is less than. Now I'm going to put target.length. I haven't set up what target is, but yeah. And then what we're going to do is that target I equals 0 times ff, and I always like to set it as pink. Now the reason I set it as pink is just because pink's a nice identifiable colour that really, you know, it won't be created accidentally by the program. Now the reason I've done it like that as well, just so you're aware, the reason I've done it like this is so that the target and the width are included. In here what we're going to include is pixels and this dot width, or this dot weight, this dot width. This makes it easier when I'm actually rendering pixels. There you go. And we'll put this in as well. This makes it easier when you're rendering, just because now I don't have to constantly reference engine every time I want to do it, and it beats making pixels public, which makes it a bit more awkward doing it that way. Yeah, leave that as private. So now basically, if I render this, you'll see we've got a nice pink screen. So we can now draw anything we want on the screen, really. Like if I could show you a way as well, I'll do in a second, to include images into it, so you can load like PNG files. They'll load into it and then you can draw them onto the screen as well, or you can create something in the game as well. Obviously using just 4 functions there and a total of 25 lines. Of course a lot of that as well is white space, like, what is that, 1, 2, 3, 4, 5, it's actually 5 lines within functions, and we've got this window drawing at 60 ticks per second and 340 frames per second, which in my opinion is quite cool. Yeah, so let's what should we do next? We can create another class. We can go for images. I'll have to create a quick image. Let's just over an engine. So what I'm going to do is go to navigation. That's what I need to do. In engine, we're just going to make a new folder. And we'll call it res. Yeah, in engine, we're just going to call it res. And this is obviously where I'm going to store all resources. And I'm just going to quickly open Paint.net. Paint.net I really like. It's like an upgraded version of Paint. Ooh, install notes. Yeah, it's like an updated version of Paint. It gives you a few extra things to do. And one of the main reasons I like it is I can do this on it. I can go to Effects, Render, make a grid or a checkerboard, and put this at 32. And I do want to reverse these really. Use source canvas for second colour. They are the wrong way round. Let's switch. Right, so I'll have to switch them quick and then go back in. 32 and like that. Right, so now what we've got is we've got a grid of 10 by 10, 32 by 32 sized images. And the first thing I normally create, to be honest with you, is just like a grass tile, because obviously the first thing I'm always going to go for is building a level. And so I'm going to go ahead and do that now. I'm going to build a little grass tile. I'm just going to choose a nice green. I quite like that green, I think. And then we're just going to go to render and add a bit of noise to it. Not that much noise, just a little tiny bit of noise. The reason we add a bit of noise is just so that we can make it look a bit normal. If we just had it plain green, it'd look a little bit weird. We're going to put this into textures. We'll just leave this actually on the main screen. Just call it tiles, like so. Okay. So that's saved. Now what we're going to go and do in here is we're going to go and we're going to make a public image and call it img. Make this a new image. I can't even spell. The source that we're going to include is res/tiles.png, and that's all we need to include, to be honest with you. And we're going to create the class image, and of course we're going to create this into engine. What I'm going to do though is put engine.gui, that's HUI.gui, generated users interface. So this is going to include all stuff like images and stuff like that. This is the better navigation, so I want to see this, because you're going to actually be able to see GUI being included in the engine, rather than if I go back to packages, you can see engine.gui included. So obviously what we've also done is we've created a constructor in here, and just by doing that, that's what I wanted. So what I'm going to do is we're going to start off by creating a new buffered image, and just call this img equals new, no it doesn't, equals image io dot read. We're going to create a new file, and we're going to do this using file name. Now, one thing I haven't done is we're going to put a try and catch function around this, and that just simply looks like so. All this means is obviously it can fail. Oh, that's not what I wanted it to do. Get message system dot out. Dot print that, that's what I wanted, not out. There you go, e.get message. So this basically what this does is obviously if file name doesn't exist, which at the moment it won't because I'm not even including file name. If file doesn't exist, then it will just print a red message down the bottom for me telling me which file it is that can't be read. And obviously this will help me out, so then I'll be able to find where that's going wrong and change it. Next we're going to do this .w equals image dot get width. Okay, is it because I'm not making image first? Maybe that's why. If image equals null, just return. This way it won't just fail, it will just tell me that it can't do what it wants to. Very far from last thing. We're just going to make a private integer up here called width, height, and then make a private integer array and call this pixels.